Hi everybody, welcome to another video in Calculus 1, section 7.5, inverse trigonometric functions. Of course, we learn about derivative and integral of the inverse trigonometric function. So that should be the calculus for inverse trigonometric function. Anyway, we still need to review a little bit about inverse trigonometric function. So just like inverse function, we want it to be one-to-one because only one-to-one function has inverse. Unfortunately, all the trigonometric functions are periodic. Periodic function cannot be one-to-one. Right? If it repeat the y values in some certain period, then if the y value repeated, it cannot be one-to-one because the horizontal line test will fail for sure. So in that case, we have to limit the domain, so the function will be one-to-one. So the sine function is like this. If we have restrict using the first quadrant here, it will be one-to-one. But we need some negative values. So we can take some negative values here, but we want the function to be continuous. So in that case, we will pick this part. So for this part of the function, we will cover all different y values. And for those y values, there's only one corresponding x values. So in that case, if we want to have one-to-one, we have to restrict the domain for sine to be between negative pi over 2 to pi over 2. Likewise, for cosine, we need to restrict in the first quadrant. And then we need some negative values for y. So we're going to pick these values. So in that case, for sine inverse, we have quadrant 4 and quadrant 1. For cosine inverse, we restrict in quadrant 1 and quadrant 2. And with that, we can define the inverse. Of course, I'm going to put a summary of this later. Right. Now, the properties. Of course, this will extend to all the trig in other inverse trig function. Of course, different domain, different range. But in general, the inverse and the function, the computation will give us back to x. So that's what we have here. Right. Now, of course, we have to restrict the domain and range. Sine inverse of sine is equal to the same thing if x is between this domain, and the sine and sine inverse equal to this if x is between this domain. Right. Same thing for cosine and cosine inverse. Of course, the domain and range may be different, but the concept is the same. Right. Just need to watch out for something. Sine and cosine is defined everywhere. So this is always defined. However, it might not be equal. Next, it might not be defined, but when it is defined, it will equal to x. So, difference between these two is, this one is always defined, but they may not be equal. This one may not be defined, but if it is defined, it will be equal to. So, keep this in mind. The function will cancel the inverse if it is defined. The inverse may not cancel the function because they have to depends on the domain. So we will say this one more time. That one is always defined but may not be equal. It is equal if we have that domain. This one may not be defined, but if it is defined, it will be equal to. So that's the difference between these two. Of course, cosine and all the other trig functions will do the same, but we just have different domain and range for the problem. So what is sine inverse of that? So if we need to do the sine inverse, I just use a calculator. If you use the inverse using the calculator, make sure it is in the degree mode. So then we can say sine inverse of negative square root of 3 divided by 2 is negative 60 degree. Negative 60 degree is negative pi over 3. And cosine inverse of negative 1/2 is 120 degree, which is 2 pi over 3. Now, we have these two. If this is defined, then that equal to negative 2. And that will equal to, if it is defined, it will be cancelled. However, if we type it is undefined, because sine and cosine have to be between negative 1 and 1. This is negative 2. So because it is undefined, so it's not going to cancel. If it is defined, it will be cancelled. So be mindful of that. Now, and then the inverse, sine inverse of sine of pi over 9. It is always defined for sure, but is that going to be cancelled? Do the inverse and the function cancel here? Well, that depends. If x is in that domain, then yes, and pi over 9 is in that domain. So yes, they will cancel out. Right. Of course, we can check. Make sure this is in the radian mode. And then we have sine inverse of sine of pi over 9. And say, how do we know it's correct? Well, take pi divided by 9, and that's exactly what we have. Right, so that's good there. Right? Now, if we have something like something that is not in this range, for example, 4 pi or 2 pi over 3. Let's try that. And 2 pi over 3. You see, they're not the same, right? So it is defined, but they might not always equal to. It is equal to if it is in the right domain. Right, so how do we do something like this? Well, just do one by one. What is sine of 2 pi over 3? Well, that is that. Right? Sine of 2 pi over 3. Let's do the inside first. 2 pi over 3 is going to be square root of 3 over 2. And now we just do the inverse. When we do the inverse, I prefer to have the calculator in the degree mode. Now square of 3 over 2. 60 degree, which is pi over 3. Of course, they don't cancel out, but the answer is going to be between negative pi over 2 and pi over 2. Right. Now, that's nice and all, but that is not the focus on this section. Focus on this section, of course, the calculus aspect of it. But before that, let's just define all the other inverse trigonometric function. We have the domain and range. So tangent, if we want that to be 1 to 1, we'll restrict the domain into his, which is also quadrant 1 and quadrant 4, similar to sine. But of course, there's no endpoint here, not equal to. Second is 1 over cosine. Second inverse, we have that is similar to the domain and range for cosine, but without the midpoint. Right, cosecant, cotangent, of course we have all of that. We summarize this in the next page later. But now, what's most important in this section is to be able to do something like this. Once you can do this, this is more than half of the problem. When we can check the phi derivative of the inverse function, we need to be able to do something like this. Right, so sine of tangent inverse of 1 over 3. So what we need to know is first, when we take the tangent inverse or any trig inverse, it's going to give us back the angle, right? So that's what we start with. Let an angle be the inverse function. Then we can take the inverse on both sides. I'm sorry, take the tangent on both sides. The function always cancel the inverse if it is defined. And the problem we have to assume that it is defined, so we can do it pretty much. So here I would apply the function to it. The function will cancel the inverse. That cancel out, so that equal to 1 third. So we have tangent of theta is equal to 1 over 3. Now, ask you, what is the ratio for tangent? Well, definition, that is, so if we have a right triangle, tangent is opposite over hypotenuse. So in this triangle, the opposite of that theta is 1, adjacent is 3. Because of that, the hypotenuse given by Pythagorean theorem will be square root of 1 square plus 3 square. Right? Be square root of 10. Right? So Pythagorean theorem. And then with that, the rest should be easy. By the way, hypotenuse is always positive, so we don't have to worry about that. Opposite and hypotenuse. If we use x, y, and r, x and y could be negative. R cannot be negative. So now with that, we can go back to our problem. We have sine of that inverse, tangent inverse, but that tangent inverse is theta. So pretty much we just need to find sine of theta. And then we say, what is the ratio for sine? It is opposite over hypotenuse. So what we have here is opposite is 1, hypotenuse square root of 10. So that's what we have. Simple enough, right? Yeah, usually there may be a plus or minus in here, but usually it's going to be positive. So let's see if it works. Let's keep things in radian. Unless I want to just do the inverse. Right, let's do sine of tangent inverse of 1 over 3. It's positive that. Right, is that 1 over square root of 10? It is. So it's good. Yeah, and that's all we do. Right. So let inside to be a variable. Take the function on both sides, draw a triangle, and then find the trig function here. Right, let's look at another example. In the interest of the next part of the problem, instead of write this theta, I will use that y. Of course, we can use any variable we want to. Right, so let's start with let y equal to that inverse. Right, we want to get rid of the inverse. We'll take the function. The function will cancel the inverse. That cancel out. sine of y is equal to negative 1/2. The sine is opposite over hypotenuse. So the angle is y. Opposite, well, hypotenuse we're going to choose to be positive. So in that case, opposite is going to be negative 1. And the equation will be hypotenuse square minus negative 1 square. Of course, it could be plus or minus. Yeah. So hypotenuse is going to be positive. Opposite and adjacent could be negative, could be positive. So that's why we have plus or minus here. And then with that, we go back to our problem. We have cosine of the sine inverse, which is cosine of y. Now cosine, the ratio is adjacent over hypotenuse. So adjacent we have plus or minus square root of 3, and over hypotenuse is 2. My question is that going to be positive or is that going to be negative? Well, go back. The sine inverse. The sine inverse is going to be between negative pi over 2 and pi over 2. So I would say the sine inverse is in quadrant 1 and quadrant 4, and cosine of quadrant 1 or quadrant 4 is going to be positive. So let's say I will write this. Sine inverse of something is in quadrant 1 or quadrant 4. And then we have cosine of quadrant 1 or quadrant 4. I should say or is going to be positive. So that's why it's going to be positive. So cosine of sine inverse negative 1/2 is going to be positive square root 3 over 2. Right. Now, of course, we can check cosine of sine inverse of negative 1/2 or negative 0.5. Is that square root of 3 over 2? Because if you do in our problem, then you know it is. Yeah. So that's good. Right. So I'll just do the inverse and see what quadrant is that. And then we have quadrant 1 or quadrant 4. Either case, cosine of quadrant 1 or quadrant 4 is going to be positive. So that's what we have. Next is the cosine of the cotangent inverse of that. And so, same thing. Now let y be the inverse strict function in sine. That's where we start with. Let y be the cotangent inverse of u. If we want to get rid of that, take the function on both sides, the function, we cancel the inverse. This will be u, right? Let's cancel out, we have cotangent is u, let's say u over 1. We need the ratio, do we? Right. Now, cotangent is reciprocal of tangent. Tangent is opposite hypotenuse, so I mean opposite adjacent. So this is adjacent of opposite. right? So we draw a triangle. The angle is y. Adjacent is u. Opposite is 1. Hypotenuse is always positive. Square root of u square plus 1 square, or u square plus 1. 1 square is still 1. Right. So we have that. Simple enough. Hypotenuse is always positive though. Yeah, adjacent or opposite may be negative. If we use in terms of x, y, and r is always positive. X and y could be negative. But I don't want to use x, y, or r because we may have x and y in the formula. Right. Now, we go back to our problem. Cosine of cotangent inverse of u. And cotangent inverse is y. So we have cosine of y. Cosine is adjacent over hypotenuse. Adjacent is u over hypotenuse square u square plus 1. Yeah. Right. So be able to do something like this. Take the inverse inside and cotangent adjacent over opposite. Draw the triangle adjacent over opposite. And then find the hypotenuse. Put everything back. Adjacent over hypotenuse. That's what we have. Right. Now before we go to the calculus part, let's just complete this table to get important. Right. So, I said, we need the function to be 1 to 1. So the domain has to be, the range will have to be something. But first, in this case, there will be 3 types of the domain. First, sine inverse will have to be between -1 and 1. You can just go back to the previous part of the note. This will be -1 to 1. And -1 to 1 for sine and cosine inverse. So if we draw the number line, it will be between -1 and 1. Right. Tangent inverse and cotangent inverse. It will be -pi/2. Negative infinity to infinity. So the whole number line. And then cosecant will be outside of -1 and 1. But you can always go back to because what we have to pop in the note. So we have the number line. It will be outside 1. Right. So that 3 different type of domains. Sine cosine inverse are the same, tangent cotangent inverse are the same, secant cosecant inverse are the same. Now in terms of range, there are only two types of one. So sine inverse will be in quadrant 1 and quadrant 4. In particular, negative pi over 2 to pi over 2. That's for sine inverse. Cotangent inverse. See if I be in quadrant 1 or quadrant 2. In particular, 0 to pi. Right, tangent inverse. Tangent inverse is the same thing as sine. Almost the same thing as sine. Quadrant 1 and quadrant 4. Except we don't have the endpoint. Cotangent inverse will be similar to cosine, except we don't have the endpoint. Once you can refer back to this. Cosecant. Well, cosecant is 1 over sine, so this will be similar to sine. Similar to sine. However, it's not going to be exactly like that. Similar to. But what we don't have is the midpoint. So we don't have the point at the middle. And then secant is 1 over cosine. Being quadrant 1 and quadrant 2. Similar to that, but no midpoint. So write a little note here. Tangent and cotangent. For those two, similar to that, but no endpoint. And these two just like that, but there's no midpoint. But you can always go back and just summarize what we have in the table. Right. But bottom line is be able to do something like this, which is the most important. Right. Now, we go to the calculus part of it. So we have the derivative of sine inverse is equal to this. So how do we prove it? Actually, I don't even memorize it. Every time we see this problem, just go ahead and prove it. So, except we don't need to memorize this. So, the proof here, just write down the problem first. Proof. What is derivative of sine inverse? In order to do that, first thing I do is let y equal to sine inverse, right? And then we start from there later. So that's what we start with. Now, if we want to get rid of the inverse, that's where we take the function on both sides, right? The function, we cancel the inverse. If it is defined, and we have to assume that it is defined, that's why we write this. we don't want to be equal to 0 either, because I mean we don't want divide by 0. That's what I mean. So, right, but for now, sine inverse cancel out, so we have sine of y is equal to x. Simple enough. But that's not the end of it. What we do here, of course, we differentiate with respect to x. If we differentiate with respect to x, assume y is a function of x. So y is a function of x. So make sure that we can put the parentheses around it, signal that y is a function of x. But derivative of sine is going to be cosine of something, and then derivative of that, because y is a function of x. So if you put y here, derivative of x with respect to x is 1. So I have cosine of y times y prime equal to 1. So if we want to solve for y prime, which is derivative of sine inverse, right? So y prime is equal to 1 over cosine of y, right? We want to find the inverse of y, which is inverse of sine. I mean, we want to find derivative of y, which is the derivative of sine inverse. Now, which is good and all, but if the function is equal to x, now this we should write that in terms of x, right? Cosine of y sine inverse of x. Now, just need to write everything here, simplify that in terms of x. That's what we have. So, right? Yeah. So function cancel the inverse, derivative implicitly. That's what we have. Now, if we have sine 1 is equal to x, now let's go back to that, and we solve for this sine y equal to x, right? So let's write that over here. Sine of y is equal to x over 1, which is opposite over hypotenuse. Sine is opposite over hypotenuse. Then let's draw a triangle. The angle is y. Opposite hypotenuse is 1. And so this will be, the equation will be 1 minus x squared. And it could be plus or minus, but the reason we don't worry about that here, because sine inverse is going to be in quadrant 1 and 4. Cosine of that is going to be quadrant, it's going to be positive. So that's why the answer is going to be positive. Right. So in that case, cosine of y is adjacent over hypotenuse. So we don't even need to write like this. We just have adjacent over hypotenuse is 1. Divide by 1, we don't need to write that, so it's just 1 over 1 minus x squared. So we don't even need to write this. Just know that cosine is equal to adjacent over hypotenuse. Just solve for that. That's what we have. Of course, don't even need to memorize that problem, because the proof is not as bad. Right? But that's usually the case. Right? So, let's try another one. prove that to find derivative of tangent inverse. That is our problem. So before we do that, let y go to tangent inverse, and then we just find y prime. Right? So we start with let y be the tangent inverse. Then we will take the tangent on both sides to cancel the tangent inverse. So tangent of y is equal to x. Right. Of course, later on we will solve for that. But for now, we'll focus on the calculus part. We differentiate this with respect to x. Right, derivative of tangent is secant square. But since this is the function of x, so y is a function of x, so that's why we have secant square of y and then y prime. Derivative of x is 1. So we solve for y prime. One over secant square of y, or we should say secant square. Right. Now, what is secant square? What is secant, by the way? Now, let's look at this. Continue over here. Right, tangent. Let's write that as the ratio. Tangent is opposite over adjacent. So let's draw a triangle. Angle is y. Opposite is x. Adjacent is 1. So this should be x squared plus 1 squared, or x squared plus 1. Square root of x squared plus 1. Then we will write secant of y will be equal to, that's what we want. A secant is going to be equal to 1 over cosine. So hypotenuse over adjacent. Hypotenuse over adjacent, so that's just square root of x squared plus 1. So I put that back in here. Square cancel square root, we just have 1 over x squared plus 1. Right. So that's exactly what we have. Derivative of tangent inverse is 1 over x squared plus 1. Right. Don't even need to memorize that, because we can derive them. Right. Now, let's work something a little more complicated. Of course, we have all the derivative rules for all the inverse trig function. It's going to be like that. Right. Now let's just going to do that by hand. By that I mean don't need to memorize all of this. So our y equal to cosine inverse of 3x squared plus 1. So to get rid of the cosine inverse, we'll take cosine both sides. Cosine inverse, we have cosine of y. Cancel that, we have 3x squared plus 1. Right. Focus on the trigonometry later. Now just focus on the calculus. Differentiate both sides. Notice that it's not going to be equal just x, right? Because we have the function, which is something more than that. Cosine only cancel the inverse, so we still have 3x squared plus 1. Now, differentiate with respect to x. Derivative of cosine is negative sine. And then chain rule says to multiply by derivative of that function. Derivative 3x squared plus 1, that's 6x. So we can divide that on the other side. Will be negative 6x over sine y. Yeah, we just need to know what is sine y, and that will be it. Now we will take this cosine of y. Let's write that as a ratio. And that ratio is, of course, cosine is adjacent over hypotenuse. Right. Triangle. Adjacent over hypotenuse. In that case, the opposite will be plus or minus, but it's going to be just positive. Hypotenuse square, 1 square or 1 minus 3x squared plus 1 square. Yeah, so that is the opposite. And finally, sine y is opposite over hypotenuse. Hypotenuse is 1. Divided by 1 it itself, so we just have that square root. So put that together, we have negative 6x square root 1 minus 3x squared plus 1 square. Right. So that one we have the derivative. Of course, we don't need to memorize all of that, but cosine inverse is going to be negative. So that's what we have there, right? Yeah, so yeah, the reason we don't have the plus or minus in the square root, because essentially here we have sine of y, and sine of y, y is cosine inverse. And cosine inverse gives us in quadrant 1 and quadrant 2, sine of quadrant 1 and quadrant 2 is going to be positive. So that's why it's going to be positive. Right. I mean positive square root. Right, now let's do this. Of course, if we want to get rid of the inverse, we'll take the same function, the function, cancel the inverse. But I don't want to write f of x. Let's use y instead. Yeah, so let y equal to, yeah, let's just so that's what I start with. Let y equal to cotangent inverse of 3x minus 5. Right. Then to get rid of the cotangent inverse, I will take cotangent on both sides. cotangent cancel cotangent inverse. So cotangent of y is equal to 3x minus 5. Now with respect to x, derivative of cotangent is negative cosecant square, and then we have derivative of that function of x, and derivative of 3x minus 5 is 3. Right. So y prime is going to be 3 over the negative cosecant square. Let's write cosecant square like that. Now we just need to determine what is cosecant. Substitute that in here and we're good. Right. We have cotangent is that. Cotangent. Let's write that as a ratio. Cotangent, reciprocal of tangent. Tangent is opposite adjacent, so this is adjacent of opposite triangle angles y. Adjacent 3x minus 5. Opposite right. Right. Adjacent is 3x minus 5. Opposite is 1. And hypotenuse is 1 square, which is 1 plus 3x minus 5 square. So that is a hypotenuse. So if we want cosecant, which is 1 over sine, is opposite over hypotenuse, which is hypotenuse over opposite. I mean reciprocal of sine. Hypotenuse over opposite, which is 1. Of course, divide by 1 is itself. So I just have the square root. Square cancel the square root. So we end up with negative 3 on top, at the bottom 1 plus 3x minus 5 square. Of course you can just use the formula in the table and then you should get the same thing, but recommended to do it this way so we don't have to rely on the formulas. Right, so that is the derivative of the inverse trig function. Of course, if we have the derivative, let's say sine inverse, derivative of sine inverse is that if we want to integrate, we just go backward. So integral of 1 over square root of 1 minus x squared is going to be sine inverse of x. Right? In particular, we have this. By the way, we'll study more of this in calculus 2. Again, I don't memorize any of this because there's a way to do that without memorizing it. It takes a few steps, but the room for error when we try to do the math is less than when we try to memorize it. Right. So, in this case, like I said, I'm just going to use those formulas. Right. So first, without anything. The integral, when there's a constant, I can check that, move to the outside. Because what we need is that, let's do the x. What we need is the one on top, and then this look like the first formula here where a is equal to 3. So this where a is equal to 3. Let's just rewrite this even better. Yeah, a is equal to 3. So a is equal to 3. According to that formula, will be just sine inverse of x over a. So that's what we have. Next, on this one we have to do a few things here. First, I'm going to move the dx to the back. Like the problem, we have a squared plus x squared, so this is not quite the right form, so I need to do something here. So we need to turn this into just x1, I mean x squared. So in that case, I will multiply 1 over 16. And 16 cancel out, so we just have x squared. Multiply the bottom. The top, don't do anything. Just check that on the outside. Multiply 16 cancel that x squared, and that 1 over 16. Sorry. 1 over 16. I can write x squared. 1 over 16 is 1/4 square. Right. Now we're going to write that formula where a is equal to 4. And the integral will be equal to 1 over a tangent inverse of x over a plus c. That's the integral, because we still have 1 over 16. So we have 1 over 16, 1 over a, 8, sorry, is 1 over 4. So we have 1 over 4, 1 over a, tangent inverse x over a plus c. Right. A finally divided fraction is multiplied reciprocal. Same thing here, that just turned to be 4x. And so we have this will be 1 over 16, sorry. That cancel out, we have 1 over 4 tangent inverse of 4x plus c. Right, so in this case we just use a formula as given. I said when we go to calculus 2, there's a way to do that without relying on memorizing the formula. But if we use a formula, that's what we have. Yeah. Right. I'll stop the section here. As always, thank you for watching. See you in another video in Calculus 1.